Hello, grade 12s. Before we get into our unit on acids and bases, we're going to take a little bit of time to practice doing the common names for acids. In grade 11, we talked about binary names for ionic compounds, and while those still apply, in grade 12 you have to be able to give acids their acid common name as well. How do you know if something's going to be an acid? Well, the simplest way for us to tell is that acids start with hydrogen. And hydrogen, we know, forms a +1 ion. Hydrogen is a cation, and therefore would like to bond to any kind of anion. So anytime we have a compound that starts with hydrogen, we can give that compound an acid name. Now, the name we're going to give it for acid naming is going to depend on the type of anion that we're using. Some anions contain oxygen. These are called oxyions. These are the ones that end in -ate or -ite on your periodic tables. Some anions do not have oxygen. These are usually our monatomic anions, things that are just made up of one individual atom, like chloride or bromide. So whether or not that hydrogen is attached to an oxyanion or not changes the naming rule we will use for the acid. Let's take a look at the oxyions first. Now, whenever hydrogen attaches to an ate ion, we would call this an ic acid. If hydrogen attaches to an ite ion, we would call this an us acid. Let's do a couple of examples. Suppose that we want to combine hydrogen, which we know always has a +1 charge, with chlorate. Chlorate is a ClO3 grouping and has a charge of -1. When we do a crisscross, we can get the formula HClO3, which in grade 11, and still is correct, we could name hydrogen chlorate. Because the anion is chlorate, we can now give this the common acid name of chloric acid. So this is true of any ate ion. Suppose we have hydrogen with phosphate. Hydrogen gets +1. Phosphate is a PO4 with a -3 charge. So because this is phosphate and -3 here and +1 there, when we do a crisscross, we get H3PO4. Hydrogen phosphate would become phosphoric acid based on the phosphorus ion. So anytime our ion ends in ate, what we end up forming is an ic acid for its common name. How do I name ions if they end then in ite? Well, we would follow the same rules. Hydrogen, for example, if it combines with chlorite, ClO2 -1, gives us HClO2 after our crisscross, hydrogen chlorite. Ite ions become us acids. So this now, based on the root anion, would be chlorous acid. Let's try hydrogen, this time with sulfite. Sulfate is SO4 -2, so sulfite is SO3 -2. Remember, the ite ion always has one less oxygen than the ate ion. Doing a crisscross, we get H2SO3, hydrogen sulfite. This would become sulfurous acid. What do we do, however, what naming rule would we follow when hydrogen wants to join with a monatomic ion? Well, when hydrogen joins with monatomic ions, it's very similar to when hydrogen joined with ate ions. It's going to end in ic acid, but now we're going to have a prefix, and the prefix is going to be hydro. So hydrogen, +1 charge, when it combines with chlorine, a monatomic ion, there's no oxygens here, it would be HCl, hydrogen chloride. This now could be named hydro from the root anion, chlorine, we're going to have chloric acid, hydrochloric acid. If I have H and sulfur, which makes a -2 charge, when these combine, we're going to get H2S. Because there's no oxygen, we start again with hydro. The anion, that makes this unique as sulfur, so this becomes sulfuric acid. Hydrosulfuric acid. So hopefully this helps us with how do I change a binary name into an acid name. There's lots more practice in your textbook on pages 250 to 252. So if you follow along in your textbook, there is lots of practice there for you to practice naming acids. There's a good set of questions 19 through 24, and those are on page 251, and those would be a good set to do. You may also practice by doing questions 31 to 36 on page 252. And there is two different pages on acid naming in your blue workbooks for us to practice. It's going to be important for you guys to practice and get good at naming acids and bases, because throughout the unit we are going to be using the official acid base name for all acids and bases that we use.